Good day everyone, I am Maria Erica C. Corona together with Aliana Paris Castro and Dan Justin Cantillo. And now we are going to report the orthonormal-based Gram-Schmidt process. And here's the objectives. First, we need to show that a set of vectors is orthogonal and forms an orthonormal basis. Use a vector relative to an orthonormal basis. Apply the Gram-Schmidt orthonormalization process. Orthogonal and orthonormal set. A set of vectors in an inner product space is called orthogonal when every pair of vectors in is orthogonal. If in addition, each vector in the set is a unit vector, then is called S-orthonormal. Example 1. Show that the set is an orthonormal basis for R3. S is equals to B sub 1, B sub 2, B sub 3. 1 over square root of 2, 1 over square root of 2, and 0. Yun yung equivalent ng B sub 1. So, yung B sub 2 naman, yung negative square root of 2 over 6, square root of 2 over 6, tsaka yung 2 square root of 2 over 3. Yung V sub 3 naman, meron siyang 2 over 3, negative 2 over 3, tsaka 1 over 3. Now, we need to show that S is an orthonormal basis for R3. An orthonormal basis is a set of vectors that are mutually orthogonal. For example, perpendicular and have a length of 1. In other words, each vector in the basis is normalized and the set spans the entire vector space. Now, we need to show that the vectors in S are mutually orthogonal. To do that, we need to calculate the dot product of each pair of vectors and show that it is equal to 0. So, let's calculate the dot products of the vectors in S. B sub 1 times B sub 2 is equal to 1 over square root of 2 times negative square root of 2 over 6 plus 1 over square root of 2 times square root of 2 over 6 plus 0 times 2 square root of 2 over 3 is equal to negative 1 over 6 plus 1 over 6 plus 0 is equal to 0. B sub 1 times B sub 3 is equal to 1 over square root of 2 times 2 over 3 plus 1 over square root of 2 times negative 2 over 3 plus 0 times 1 over 3 equals square root of 2 over 3 minus square root of 2 over 3 plus 0 is equal to 0. B sub 2 times B sub 3 is equals to negative square root of 2 over 6 times 2 over 3 plus square root of 2 over 6 times negative 2 over 3 plus 2 square root of 2 over 3 times 1 over 3 is equal to negative square root of 2 over 9 minus square root of 2 over 9 plus 2 square root of 2 over 9 is equal to 0. Since all the dot products are 0, we can conclude that the vectors in S are mutually orthogonal. Next, we need to show that each vector in S has a length of 1. To do this, we need to calculate the Euclidean norm or magnitude of each vector, which is defined as vector unit is equals to square root of B times V, where V is a vector. Vector unit 1 is equal to square root of B sub 1 times B sub 1 is equal to 1 half plus 1 half plus 0 is equals to 1. Vector unit 2 is equal to square root of B sub 2 times B sub 2 equals 2 over 36 plus 2 over 36 plus 8 over 9 is equals to 1. Vector unit 3 is equal to B sub 3 times B sub 3. Square root of B sub 3 times B sub 3 is equals to 4 over 9 plus 4 over 9 plus 1 over 9 is equal to 1. We can conclude that S is an orthonormal basis for R3. Example number 2. An orthonormal basis for P sub 3. In P sub 3, with the inner product P and Q is equal to A sub 0, B sub 0 plus A sub 1, B sub 1 plus A sub 2, B sub 2 plus A sub 3, B sub 3. The standard basis P is equals to 1, x, x squared, and x cubed is orthonormal. The verification of this is left as an exercise.
So here's a theorem 5.10. So the orthogonal sets are linearly independent. So sabi dito, if S is equals to V sub 1, V sub 2 to V sub n is an orthogonal set of non-zero vectors in an inner product space of V, then S is linearly independent. So before we proceed, we also have here the corollary. This is an inner product space of dimension n, then any orthogonal set of n that non-zero vector is a basis for V. Since kailangan natin masabi na yung non-zero vectors natin is inner product siya ng space of V. So, paano nga ba natin masasabi yon? So, here's a proof na magsasabi na ang inner product space of V natin is non-zero vector. So, para masabi natin na yung S is linearly independent. So, first, you need to show that the vector equation is C sub 1 multiplied by V sub 1 plus C sub 2 multiplied by V sub 2 then plus C sub n multiplied by V sub n is equals to 0. Para i-explain ng maayos yung theory na yon, here's some example na meron tayo. So, using the orthogonality to test for a basis. So, dito, ipapakita kung paano gumagana yung sinasabi nating corollary. So, ang problem natin dito is, show that the following set is a basis for r raised to 4. Then we have a given or a set of S is equals to 2, 3, 2, negative 2, and 1, 0, 0, 1, and negative 1, 0, 2, 1, and negative 1, 2, negative 1, and 1. So, here's the solution na pwede natin gamitin para makuha yung vector equation. So, first, you need to multiply, or this the easy way na lang para makuha yung vector equation. First, you need to multiply the V sub 1, V sub 2, then V sub 1, V sub 3, V sub 1 and V sub 4, then V sub 2, V sub 3, and V sub 2, and V sub 4, and V sub 3, and V sub 4. So, paano nga ba siya nakukuha? Since i-multiply mo yung dalawang vectors, yung makukuha mo sa kada set nila, yun yung magiging yun yung magiging inner product. Yung may inner product nung sinasabing space ng V. So, sa pag-multiply ng V sub 1 and V sub 2, meron tayong nakuhang 2 plus 0 plus 0 minus 2 is equals to 0. Since, nakikita nyo dito na lahat ng naging answer nila is, lahat ng naging, inner product nila is equals to 0. Therefore, masasabi natin na the set of S has 4 non-zero vectors. By using the corollary, you can show that S is a basis for R raised to 4 by showing that it is an orthogonal set. So, ayan. So, masasabi natin na yung S is orthogonal set or linearly independent siya since ang nakuha natin sa dito sa inner product space is non-zero. So, we have here that S is orthogonal, and by the corollary, it is a basis for R raised to 4. Theorem 5.11, the coordinates relative to an orthonormal basis. So, sinasabi naman dito, if a set of V is equals to V sub 1, V sub 2, V sub to v sub n is an orthonormal basis for an inner product spaces of V. Then the coordinate representation of a vector W is relative to B is W is equals to W v sub 1 multiplied by v sub 1 plus W v sub 2 multiplied by v sub 2 plus W v sub n multiplied by v sub n. So, paano nga ba natin siya ipoprove na ayun siya? So, since B is a basis for V, there must exist a unique scalar such that the W is equal to C sub 1 C sub 1 multiplied by C sub V sub 1 plus C sub 2 multiplied by V sub 1 plus C sub n is multiplied by V sub n. Then again using the taking the inner product of both sides of this equation, makakuha tayo ng W and V sub I is equals to C sub 1 multiplied by V sub 1 plus C sub 2 multiplied by V sub 2 plus C sub n multiplied by V sub n, then multiplied by V sub I. Then, magkakaroon ulit tayo ng another sets or magiging siyang C sub 1 multiplied by V sub 1 and V sub I plus C sub 2 multiplied by V sub 2 and V sub I plus C sub n multiplied by V sub n and V sub I. So, and by that orthogonality of B, this equation will be reduces to this equation, or makakakuha tayo ng mas pinaigsing formula. So, W and V sub I is equals to C sub I multiplied by V sub I and V sub I. So, because V is orthonormal, you have the V sub I and V sub I is equals to V sub I squared or equals to 1. And it follows that W and V sub I is equals to C sub I. So, in Theorem 5.11, the coordinates of W relative to the orthonormal basis B are called the Fourier coefficients of W relative to B after the French mathematician Jean-Baptiste Joseph Fourier of 1768 to 1830. The corresponding coordinate matrix W of relative to B is W sub B is equals to C sub 1, C sub 2, C sub n raised to t is equals to W and V sub 1, W and V sub 2, and W V sub n, W and V sub n raised to t. So, para ma-explain ng maayos yung theory kanina, so here's a representing vectors relative to an orthonormal basis. So, ang problem natin dito is find the coordinate matrix of W is equals to 5, negative 5, and 2 relative to the following orthonormal basis for RQ. So, our orthonormal basis or our set of B is equals to 3 over 5, 4 over 5, 0, and negative 4 over 5, 3 over 5, and 0, and 0, 0, 1. So, since B is orthonormal, we can use the said theory or yung sinabing theorem kanina sa 5.11 para makuha natin yung coordinates. So, sa pagkuha ng coordinates, ipagmumultiply lang natin yung W, yung value ng W sa value ng set ng B natin or ng B natin, or magiging W multiplied by V sub 1, then W multiplied by V sub 2, and W multiplied by V sub 3. So, what is the value of W? So, meron tayo ditong 5, negative 5, and 2, imumultiply natin sa V sub 1, wherein ang V sub 1 natin is 3 over 5, 4 over 5, and 0. So, again, same procedure sa pagkuha ng inner product ng vectors. So, Sa pagkuha nun, ang naging answer natin is negative 1. So, same ng procedure sa pangalawa, sa W multiplied by V sub 2. So, we have 5, negative 5, 2 multiplied by negative 4 over 5, 3 over 5, and 0. So, ang naging answer is negative 7. So, last is the W multiplied by V sub 3 is equals to 5, negative 5, and 2 multiplied by 0, 0, 1. And the answer is 2. So, the coordinate, sabi dito, the coordinate matrix relative to B is W sub B is equals to negative 1, negative 7, 2 raised to T. So, the Gram-Schmidt orthonormalization process is, having seen one of the advantages of orthonormal bases, the straightforwardness of coordinate representation. This procedure is called the Gram-Schmidt orthonormalization process after the Danish mathematician Jørgen Pedersen Gram of 1850 to 1916 and the German mathematician Erhard Schmidt of 1876 to 1959. So, sabi nila, meron tayong tatlong steps para dito sa process na to. So, first is begin with the basis for the inner product space. It need to be orthogonal nor consist of unit vectors. Second is convert the given basis to an orthogonal basis. Then the last step of this process is normalize each vector in the orthogonal basis to form an orthonormal basis. So, the other theorem is discussed by Mr. CANTILLO.
Theorem 5.12, Gram-Schmidt orthonormalization process. So, we have here number 1, let V is equals to V sub 1, V sub 2 hanggang V sub n be a basis for an inner product space V. And let B prime is equal to W sub 1, W sub 2 hanggang W sub n, where W is given by, we know that W sub 1 is equals to V sub 1. What I'm trying to say is, kung ano yung magiging value ng V sub 1, ayun din ang magiging value ng W sub 1 natin. So, next, W sub 2 is equal to V sub 2 minus V sub 2 plus W sub 1 over W sub 1 plus W sub 1 times W sub 1. So, ayun yung magiging formula natin para makuha natin yung value ng W sub 2. No? So, sa W sub 3 naman, magkakaroon tayo ng V sub 3 minus V3 plus W sub 1. W sub 1 plus W sub 1 times W sub 1. Ito dito sa gilid, minus V sub 3 plus W sub 2 over W sub 2 plus W sub 2 times W sub 2. So, then, B prime is an orthogonal basis for B. So, para naman sa magiging U natin, so let U is equal to W sub 1 over the norm of W sub 1, then the set of B second prime is equal to U sub 1, U sub 2 hanggang U sub n is an orthonormal basis for B. So, moreover, span V sub 1, V sub 2 hanggang V sub k is equal to the span of U sub 1, U sub 2 hanggang U sub k for k is equals to 1, 2 hanggang n. Now, we will try this theorem to example number 6. So, dito na tayo sa example number 6. applying the Gram-Schmidt orthonormalization process. So, we have here a given. So, kailangan natin ng basis for R. So, B is equal to set of 1 and 1 and 0 and 1. So, we know that 1 and 1 is our V1 and 0 and 1 is our V2. So, W sub 1 is equal to V1. So, sabi ko nga kanina, kung ano yung magiging value ng V1 natin, ayun yung magiging value ng W sub 1 natin. So, okay na tayo doon, no? Ano ba yung value ng V sub 1 natin? Ito, 1 and 1. So, sa W sub 2 naman, kailangan nating isolve muna ito bago natin makuha yung final na sagot para sa W sub 2. So, V sub 2 minus V sub 2 times W sub 1 over W sub 1 times W sub 1 times W sub 1. So, we know that the V2, the value of V2 is 0 and 1 minus, copy lang natin yung minus. So, paano natin nakuha yung 1/2? So, nakuha natin yung 1/2 dahil sa, unahin muna natin itong V2 times W1. Paano nakuha yung sagot na V2? Ay, yung sagot dito. So, yung V2 natin, ano yung V2 ulit natin? Yung V2 natin is 0 and 1. Tapos, yung W sub 1 natin is 1 and 1. So, 0 times 1 plus 1 times 1. So, 0 times 1 is equal to 0 plus 1 times 1. So, 1 times 1 is 1. So, 0 plus 1 is 1. Kaya nakuha yung 1 dito. Over natin kasi may over siya dito. So, W sub 1 times W sub 1. So, ano yung W sub 1 natin? W sub 1 natin is 1 and 1. So, 1 and 1. So, pareha sila. 1 and 1 and 1 and 1. So, 1 times 1 plus 1 times 1. So, 1 times 1 is 1 plus 1 times 1. So, yung 1 times 1 natin sa kabila is 1. So, 1 plus 1 is 2. Kaya nakuha yung 2. Kaya, naging 0 and 1 minus 1/2 times anong value ng W sub 1 natin? 1 and 1. So, ayun. So, paano naman nakuha yung negative 1/2 tsaka 1/2? So, para makuha yon yung negative 1/2 times 1/2, negative 1/2 and 1/2. So, kailangan lang natin baba, no? So, W sub 2 is equal to, ito baba natin tong 0 and 1, yung V2 natin, baba natin, minus 1/2 times 1. So, 1/2. Tsaka, ayun, 1/2 times 1 ulit. O, 1/2. So, magiging 0 minus 1/2. So, 0 minus 1/2, magiging negative 1/2. No? Kaya, yun nakuha. So, tapos, 1 minus 1/2 will be 1/2. So, ang W sub 2 natin is negative 1/2 and 1/2. So, next natin, example number 7, ganun pa rin, applying the Gram-Schmidt orthonormalization process. So, dito naman, meron tayong given na tatlong So, ang una, 1, 1, 0. Yung pangalawa is 1, 2, 0. Yung pangatlo is 0, 1, 2. So, ang V1 natin is yung 1, 1, 0. V2 natin is 1, 2, 0. And yung V3 natin is 0, 1, 2. Same process pa rin yung gagawin natin. Kaso nga lang nag-iba lang yung given kasi naging tatlo siya. So, ganun pa rin. W sub 1 natin is equal to V sub 1. Kung ano yung value ng V1 natin, yun yung magiging value ng W sub 1 natin. So, sa W sub 2, ganun ulit. V sub 2 minus V sub 2 times W sub 1 over W sub 1 times W sub 1 times W sub 1. So, makikita natin dito na yung V2 natin, which is yung 1, 2, 0, minus 3, 2. Kaya nga nung sinabi ko kanina, susolve lang ulit natin yung ganon. So, ang kinalabasan natin dyan ay negative 1 half, 1 half, tsaka 0. Since meron siyang 0 doon, matik na 0 din yung dito. So, yung W sub 3 natin, para mahanap din naman yung W sub 3 natin, kung paano yung ginawa mo dito sa V sub 1, V sub 2, uulitin mo lang siya dito sa V sub 3, pero kasama na yung W sub 2. So, eto, V sub 3 minus V sub 3 times W sub 1 over W sub 1 times W sub 1 times W sub 1 minus V sub 3 times W sub 2 W over W sub 2 times W sub 2 times W sub 2. So, ang magiging sagot natin overall is 0, 0, 2. So, for the set of B prime is equal to W sub 1, W sub 2, W sub 3 is an orthogonal basis for R3, normalizing each vector in B prime produces U sub 1 is equal to W sub 1 over the norm of W sub 1. So, ano yung W sub 1 natin? Yung W sub 1 natin is 110. Tapos, yung norm, value norm natin ng W sub 1 is 1 over square root of 2. So, parang ganun lang ulit sa nauna kanina. Yung gagawin natin para makuha yung sagot. So, square root of 2 over 2, square root of 2 over 2, and 0. Yun yung U1 natin. So, yung U2 natin, so, W sub 2 over the norm of W sub 2 is equals to 1 over 1 square root of 2. So, negative 1 half, 0 is equal to negative square root of 2 over 2, then square root of 2 over 2 and 0. So, yun yung magiging U sub 2 natin. So, yung U sub 3 natin, W sub 3 over the norm of W sub 3 is equal to 1 half times 0, 0, 2 is equal to 0, 0, 1. No? So, 1 half times 2. So, B, second prime is para naman sa B prime. So, B prime is equal to W sub 1 and W sub 2 is an orthogonal basis for R2 by normalizing each vector in B prime. So, makikita natin dito sa screen na ang U sub 1 natin is equal to, para makuha natin yung U sub 1. So, since meron na tayong W sub 1 and W sub 2, kailangan na natin kunin yung U sub 1. So, U sub 1 is equal to W sub 1 over the norm of W sub 1. Excuse me. So, is equal to ano nga ulit yung ano natin? Ano nga ulit yung W sub 1 natin? 1 and 1. So, nilagay na natin dito yung nilagay na natin dito yung value ng W sub 1 natin. So, ano yung value ng norm of W sub 1 natin? Ano yung magiging value niya? So, 1 over square root of 2. No? Tapos, pagta-times lang natin, square root of 2 times 1. So, square root of 2 over 2 times 1 and 1 is equal to, ipag-times lang ulit natin yan. So, square root of 2 over 2 times 1, square root over 2. Square root of 2 over 2. And ayun lang. Pag times lang natin yan, yung square root of 2 times 2, square root of 2 over 2 times 1, magiging sagot, ito, yung square root of 2 over 2 and square root of 2 over 2. Ayun yung magiging u sub 1 natin. So, sa u sub 2 naman natin, is equal to w sub 2 over the norm of w sub 2 is equals to 1 over 1 over 1 half. 1 over 1 square root of half. So, ganun lang ulit. Ipagtatimes lang natin. Ang makukuha natin sagot dyan is negative square root of 2 over 2. Tsaka square root of 2 tsaka 2. So, yung isa, negative. Yung isa, positive. So, masasabi na the second prime of B is equal to U1 or U sub 1 and U sub 2 is an orthonormal basis for R2.